Okay, example 10. Now on to some noises and how to move points around. This is very useful and you will be using this all the time, I'm sure. I do, everyone does. So it's very good to like play around with this and like kind of have a look at different noises and what kind of values they give you and like kind of what certain situations call for, what kind of noises you need. Anyway, I'm gonna show you 3 different examples called turbulent noise, curl noise, and AA noise. So the usual thing we do is we put a sphere, we get some points from it, with the volume, points from volume, and we put some separation, and we put some jitter scale, whatever. Let's just check out turbulent noise. This tends to be the noise I use the most. I don't know why, but I feel it gives me a very good result. So noises are vectors. They put on an X, Y, and C value. If you put it to be a 3D noise, obviously, but in most cases you will do that. So yeah, noises is I would say a natural phenomenon, but I don't know what the term is really for it, but it is pretty organic if you think about it. And a lot of things around us in noise, like audio, sound waves, I don't know, whatever. But we have a lot of things here. We can play with frequency, we can play with offset, amplitude, roughness, annotation, turbulence. I'm not gonna go into too deep to these because I know for a fact we are gonna do that in later lessons, but I just wanted to show you. So this is turbulent noise. I put some offset. I put a $T expression here to move it. $T will basically grab the time, and it will put an offset of that. So 0, as you can see, the time, and the time in seconds. So it offsets it, and that's why it's moving basically. This is turbulent noise. Here we have some curl noise. This is pretty cool. Curl noise is very useful for volumes since it gets a very natural result. For moving points around, I don't really tend to use it too much, honestly, but it's teaching its own. This is curl noise. Curl is an attribute we're gonna use later on as well, which is really cool. Yeah, this is kind of the same things like offset, frequency, amplitude, roughness, annotation, turbulence, step size. This is some things that other noises doesn't have, which make this noise really complex. But we'll take a look at it later. And by the way, these are created in the VOPs, so you can go inside of them and see curl noise and an add. So basically what I do is I put the position into an add and it's some out of position, and then I add the curl noise on top of that. Because if I just straight would do like this, actually curl it does work because it's 0 centered, but for turbulent noise it would freak out. I thought maybe you need more amplitude, whatever. Sorry, I wasn't visualizing it. Yeah, it kind of goes a little bit weird, especially if it's not 0 centered. Things will go crazy. Anyway, it's a good practice to add it on. It's very good, like that. And with turbulence, curl noise, and then AA noise at the end. AA noise is pretty similar to turbulence noise, honestly. It tends to give me a little bit simpler results, which I don't really like. I don't really like using it that way, but and there's a lot of math and like science to these things, right? So you can actually go and read about curl noise, and it's an actual physical thing. So if you're really interested in that, I would definitely like Google it, or you know. But yeah, these are a couple of noises we're gonna play around with later on. I just wanted to show you guys how they would move points around, and obviously they will update their position. That's all they're doing here. They're not doing anything else. The position is offsetted by the noise, basically. So yeah, I just wanted to say that this was the last kind of segment of the points, but obviously every single example we're gonna do from here on out is gonna be with points. So don't worry, you're gonna learn all the attributes, all the ways you can use points, smart ways to use them, dumb ways to use, I don't know, but smart ways mostly. And points is the foundation of anything you want to create. Regardless if it's smoke, if it's fire, if it's water, if it's like electricity, you will in some way or regard use points. Why it's a very good base to know like these things about them and stuff. And points builds everything. Points build vertices, and vertices builds polygons, and polygons builds primitive things. So points is the foundation to everything in Houdini. So yeah, you're gonna hear a lot of them. You're gonna get tired and sick out of points. But isn't that the beauty of Houdini? Anyway, thank you guys for watching the first segment of my series. And now we're gonna go on to primitives. So I'll see you all there.